Okay, hello everyone. So you might remember from last video that the product rule is not easy. Okay, it's not easy than the what most people think it is. The derivative of the first function times the derivative of the second function. It is not. Okay, it's just a quick refresher. The derivative of f of x times g of x equals f prime g plus f g prime. Okay, so this looks kind of complicated. However, today we're going to learn about the quotient rule, the derivative of a quotient, a division of two functions. Okay, so the derivative of f of x over g of x. Okay, and you can prove this, but the derivative of this is f prime of x, so f prime g minus f g prime. Okay, so it looks like that, except it's all over g of x squared. To make matters even worse, there is a squared quantity below it. So I would condense it to make f prime g minus f g prime over g squared, where f is your top function and g is your bottom function. Now, with the quotient rule upon us, remember, we only have derivatives of sine of x and cosine of x. Now we can get derivatives of all 6 trig functions using the quotient rule. Tangent of x, cosecant of x, secant of x, and cotangent of x. So I'm just going to do the derivative of tangent of x as an example. Okay, so the derivative of tangent of x, well, tangent of x, remember trig, is sine of x over cosine of x. Sine x over cosine of x. So you can rewrite this as a derivative of sine of x over cosine of x. And we know the derivatives to both of these. So we can apply the quotient rule. So f prime, so the derivative of the top function, so that's cosine x, times the bottom function, g of x, so that's cosine x again, minus f of x, so that's the top function, times g prime of x, which is negative sine of x, over g of x squared. So that's cosine squared of x, so cosine of x squared. Now if you were to simplify the top, you get cosine squared of x plus, negatives cancel out, sine squared of x over cosine squared of x. And this should be going ding, 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 because sine squared x plus cosine squared x is probably one of the most memorable identities, 1 over cosine squared of x. So you have 1 in the numerator, and this simplifies to secant squared of x. So the derivative of tangent of x is secant squared of x. Okay, and you could use the quotient rule similarly to derive derivatives for all the other functions. Okay, so if you were to do that, you would get all the derivatives of all the 6 trigonometric functions. So I'm just going to list them out. The derivative of sine of x equals cosine of x. Good, we know that already. the derivative of cosine of x is negative sine of x. Okay, so now we also know that. We know that already. Now derivative of tangent at x we just found out was secant is secant squared of x. So the derivative of cosecant of x is negative cosecant of x times cotangent of x. Again, you can use the quotient rule to verify this. The derivative of secant of x equals secant of x times the tangent of x. And the derivative of the cotangent of x equals negative cosecant squared of x. And I keep on saying you can use the quotient rule, and you might be saying, how? There's no quotient. Well, they're hidden quotients. Tangent is sine over cosine. Cosecant, secant, and cotangents are the reciprocal functions. That means they're 1 over sine, 1 over cosine, and 1 over tangent. So now that we know the three, what I would call normal trig functions, you could use the quotient rule with 1 at the top to find the 3 reciprocal trig functions, and you would get these values. Okay? So let's do an example. So let's say we have f of x equals sine of x over x. Sine of x over x. So part A, what is f prime of x? And B was the equation of the tangent line. The tangent line at x equals pi over 6. Okay? So first, what I'm going to do is find the derivative of f of x equals sine of x over x. Okay? So this is just quotient rule application. So we have f prime cosine of x, g, put x at the front, minus, remember it's a minus sign for this one, g prime 1 times f, all of that over the bottom function squared, x squared. Okay, so f prime g minus g prime f all over g squared. Okay? So now, let's put a little prime sign just so we don't get confused. So what's the equation of the tangent line at x equals pi over 6? Well, what's f prime of pi over 6? Well, that equals pi over 6 times the cosine of pi over 6 is root 3 over 2 minus sine of pi over 6 is 1/2 over pi over 6 squared, which is pi squared over 36. Good. So if we were to simplify this, you would get root 3 pi over 12 minus 1/2, which I can rewrite as 6 over 12 over pi 36. And we get root 3 pi minus 6 over 12 times 36 over pi squared. If we're just dividing by the fraction at the bottom, we get 1, we get 3, and we get 3 root 3 pi minus 18 over pi squared. Okay, we got the derivative. Now here comes the hard part, actually evaluating the function. Well, actually getting the equation. So we need to find the function, the actual function valued at pi over 6, so we can get a y coordinate. So sine of pi over 6 is 1/2. X over pi over 6 equals 1/2 times 6 over pi, which equals 3 over pi. Okay, so good. We're off to a good start. So good so far. Now we're gonna have to use point slope. Y minus y1 equals m, all this times x minus x1. Okay, so I'm gonna be really careful with the algebra since last video I almost made a huge mistake. Kind of silly one at that. Okay, so we're gonna have 3 root 3 minus 18 over pi squared x minus, well, this cancels with that. And if you were to rewrite this, oops, there's a pi in here. Almost did it again. Okay, so if we were to rewrite this as minus 6, okay? Cancel, 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 cancel. So we get root 3 pi minus 6 over 2 pi. So let me just check that. So good, cancel, we cancel with that, so that makes it 2. We get a pi squared cancels with a pi. Good. Okay, so far so good. Now we bring this to the right. I'm going to rewrite this as 6 over 2 pi. If we rewrite it like this, and get our final equation as root 3. 3 root 3 pi minus 18 over pi squared x. Well, we have 6 over 2 pi, so we're adding 6 to here. So we get minus root 3 pi minus 6, so negative negative would be positive, plus 12 actually should be minus 12 over 2 pi. I really hope I did this right. Okay, just scan over it, okay, just to check. And it looks just about correct. So this will be our final answer.